Okay, so picking up where we left off, recall that we had drawn our sampling distribution assuming that students were just randomly guessing, or assuming the null hypothesis is true. We had marked what our sample proportion was to see kind of how unusual it is that we would get this sample proportion if students are just randomly guessing. We talked about how, like, if we got a sample proportion of 0.57, that would be really unusual. But a sample proportion of 0.27 really isn't that unusual given the sampling distribution if we're assuming that students are just randomly guessing. And so the p-value is just going to formalize that concept by not just like saying, oh, it's not that unusual, because that's not really as descriptive as we could be. Instead, we're going to kind of attach a precise probability to how unusual our sample proportion is if students are just randomly guessing. And so how we're going to do this is we're going to bring in stuff that we talked about maybe like a week and a half ago. And so if you remember, our z-score was in general an observation minus the mean divided by a standard deviation. Well, we're going to translate this into our sampling distribution, where our observation is going to be our observed sample proportion, so that was 0.27. Our mean is the mean of the sampling distribution if the null hypothesis is true, so we could see kind of easily here that it's centered at 0.33. And then the standard deviation of the sampling distribution, which we calculated here. It's also called the standard error. So that's 0.063. If we do this calculation, you should end up with something that's almost exactly 1. I'll put 1.005, or negative 1.005. And so finally, if you go way back to the definition of our p-value, so if the null hypothesis is true, we've already taken care of that. Now we want to find the probability of getting data that is at least as favorable to our alternative hypothesis as what we actually saw. And so you could go ahead and draw your z distribution, which we know is centered at 0 and has a standard deviation of 1. You can mark the observed z on that z distribution. And now the p-value says we want to find the probability of getting data that's more unusual than what we actually observed, or more in favorable of the alternative hypothesis than what we actually observed. Well, more in favor of the alternative is going to be stuff that's away from what the null hypothesis is. And so it's going to be any kind of stuff over here, because that's going to be more in favor that the proportion is different than a third than what we actually observed, which is this line with the 0.27. Not only that, we want to consider the other side of the distribution as well, because all of this stuff is also going to be more in favor of the alternative. And so this is where we're bringing back the idea of what's considered extreme or unusual when we look at this normal distribution, and it's anything in the tails. The shaded area is going to end up being our p-value. So we could guess what our p-value is. It looks like it's about maybe 3-ish, just based on our picture. We could, once we actually figure that out, we'll end up using stat key, and we want to put this, we want to standardize it and put it on a scale that's going to be the same for every single problem that we do. So that's why we talked about standardization, using these z-scores, putting something on a different scale so that we could kind of use this z-distribution for all of our one proportion hypothesis problems. And so on our z-distribution, we're again going to shade the tails. If you drew it right, it should match up exactly with the picture on page 6. And so this shaded area is going to be our p-value. So now what you could do is go on the stat key. I'm not going to do it here, but you're welcome to do it for some extra practice. If you go on the stat key, you should be able to go to the normal distribution. You should be able to click two-tailed, and then you should be able to enter in negative 1.00 or negative 1.01. And stat key should give you these two tail areas. And so when I did this, this area was 0.159, and same with this area. And so finally, since our p-value, putting everything together, if the null hypothesis is true, what's the probability of getting a sample proportion more in favor of the alternative, so that's more in the tails than what we actually saw? Our p-value is going to be just adding those two together. And it's going to be 0.318. Okay, so we'll come back and talk about how to write a formal conclusion using this p-value. And so we'll talk a little bit more about what it really means for our original question. Again, this is the first time we're seeing all this. It can be hard to get a grasp on everything that's going on at first, but we will get to two more kind of full examples of this, just to hopefully get everyone on board with this idea about hypothesis testing.